Now we come to the projection of straight line. As you know that projection means something that we throw forward. Basically the Greek word, its meaning is something we throw forward. So we deal problems on projection of straight line. First of all, let me know what is meant by straight line. A straight line means a locus of a point which moves linearly, what we call it as a straight line. The problem of the projection of straight line, it goes like this. Draw the projection of a straight line AB 80 mm long is inclined to HP at an angle 30 degree and VP at an angle 45 degree. We should draw the projection of a straight line AB 80 mm long in which its end A is 10 millimeter above HP and 20 millimeter in front of VP. That means a line, if it is inclined to both HP and VP, how we can carry out the projection of a straight line AB of length 80 mm long. Let us say this is horizontal plane and this is vertical plane, and this is what is called as an XY line, where it is an intersection of VP and as well as HP. Now you are the observer. A straight line AB 80 mm long, now it is inclined to HP at an angle 30 degree. That means the angle between the line AB, it is at an angle 30 degree to HP, and this line also inclined to VP at an angle 45 degree, where it's the end A, this end is A and this end is called B. This end A is 10 millimeter above the horizontal plane and 20 mm in front of the vertical plane. That means your line is inclined to HP and also inclined to VP, in which one of its end of a line AB 10 millimeter above HP and 20 millimeter in front of VP. Draw the projection. Now the line is inclined to both HP and VP. If I draw the top view or front view, top view it will be an apparent length, front view also it will be an apparent length that I cannot draw because I don't know the apparent length and apparent inclinations. Then how we can do such problems? Very simple. Now fix the end A in which A is 10 millimeter above HP and 20 millimeter in front of VP. By keeping this angle theta constant, make the line parallel to VP. See, I am not changing this theta, just I am varying the phi angle in which the line it becomes parallel to VP and inclined to HP at an angle 30 degree. Draw the top and front view. Now I can draw the top and front view in this position. What the front view it will be? Front view it will be true length at an angle 30 degree, and top it will be an apparent length called AB2, which is parallel to the XY line. That is my first set of front view and top view. After that, we have to go back to the original positions where the line is inclined to HP at an angle 30 degree and inclined to VP at an angle 45 degree. What to do? By keeping this angle phi constant, make the line parallel to HP. Now when the line parallel to HP and keeping that phi constant, where I can able to draw the top and front view, top it will be true length at an angle phi called 45 degree. Front view, if I draw a line AB2, it is at an angle 0 for the XY line. That means since it is parallel to HP and inclined to VP at an angle 45 degree, front view to be an apparent length, top it will be true length. So we got two sets of top and front view. Once you obtain the two sets of top and front view, by superimposing, I may get the front and top of the line. So what I have to do? Very simple. Observe here. When I read the problem, very first important thing is I have to write the data of the problem. The data of the problem is very simple. A line AB of length is given true length, it is equal to 80 mm long. And this line is inclined to HP, theta it is given at an angle 30 degree and angle to VP that is 45 degree, where its end A is given 10 millimeter above HP. That means front view A dash 10 millimeter above the XY line, top view A it is 20 millimeter in front of VP. It means its end extremity is called A, it is 10 millimeter above HP and 20 millimeter in front of VP. Draw the projection. So very simple. Observe here. First you draw a very thin XY line with a medium pressure. Show VP, HP on either side of the XY line. Now initially you have to mark the point A. In which end A is 10 millimeter above HP, that is 10 millimeter above the XY line, and top of the point A it is 20 millimeter in front of VP. Mark A 20 millimeter below the XY line. So after marking A dash and A, Passing through A dash, you just draw a locus, and passing through A, you just draw a locus. So now, draw a locus which is parallel to the XY line passing through A dash. Now you keep protractor A dash. See, now observe here. Initially it was line like this, right? Inclined to each at an angle 30 degree, inclined to each at an angle 45 degree. Now by keeping theta constant, make the line parallel to VP. Make the line parallel to what? VP. Get the front and top view. Front view A dash, B1 dash of length 80 millimeter at an angle 30 degree. See what I have to do? Keep protractor at A dash, measure 30 degree and draw a line. See, I am drawing a line called true length. I am drawing a line called true length of length 80 millimeter at an angle theta 30 degree, and it is what is called as B1 dash. Draw A dash, B1 dash, length 80 millimeter at an angle 30 degree, and draw a locus through B1 dash. And top view also you can get. Draw a projective from B1 dash till it meets the locus of A, and this is what is called as B1. So now, initially we get the front view at the true length of length 80 millimeter at an angle 30 degree, and top it will be an apparent length called AB1. After getting the first set of top view and front view, go back to its original position in which the line is inclined to at an angle 45 degree. Make the line parallel to what? Parallel to HP. Get the second top in front view, where the second top view it will be true length. Listen here. Keep protractor at A. Draw a line at an angle 45 degree. You draw a line at an angle phi is equal to 45 degree, and this is what is called as true length of length 80 millimeter, in which it is called as B2. Mark AB2 true length at an angle 45 and draw a locus through B2. And draw a locus through what? B2, and get the corresponding front view from B2, and it is what is called as B2 dash. So now we obtain the two sets of front and top view. My interest is to get the what? The front view A dash, B dash, and the top view AB at an angle alpha and beta. How we can obtain? Observe here. So this is my front view called A dash, B2 dash. By using compass with A dash as center, A dash, B2 dash, you just draw an arc. You just draw an arc so that it cuts the locus of B. This is the locus of B. The moment with A dash as center, A dash, B2 dash as radius, using compass, if you draw an arc, it cuts the locus here, and it is called as B dash. Now join A dash, B dash, it is called as a front view called apparent length at an angle alpha. Similarly, to get the top view AB, what to do? From this true length, you project. Now with A as center, AB1 as radius called top view. If you draw an arc so that it cut the locus of B here at point B. Join AB, that is called as a top view. It is inclined at an angle beta. So when do we know that the problem is correct or wrong? If I draw a projective from B vertically down, my B and B dash should come in the same line. See, now I got the projections of A dash, B dash called front view at an angle alpha, AB called top view at an angle beta. Very simple. Observe here. If true length it is given called A dash, B1 dash length 80 millimeter, how do you get the top view? Means you have to project and rotate. See, to get the top view from the true length, you have to project and rotate. To get the true length from the apparent length, what to do? You have to tilt and project. See, that is very simple. In order to get the true length from the apparent length, observe here. Very simple. To get true length from apparent length, what to do? Very simple. To get the true length called AB2 from this apparent length A dash dash, what to do? Means you have to rotate or tilt up to its local parallelity and then project. See, to get true length from apparent length, always remember it is tilt and project. It is tilt and what? Project. Similarly, to get apparent length from what? From true length, what to do? See, to get the apparent length called A dash B dash from the true length called AB2, what to do? You have to project and then rotate. See, project and rotate, it is very simple. Project and rotate or tilt. If I do that, I will get the apparent length. So, if I draw a locus through B and B dash, these two come in the same vertical line. Similarly, B1 dash, B1 come in the same line. A dash and A should come in the what? Same line. Now the problem is very simple. Draw the projection of a straight line AB of length 80 millimeter, where it is inclined to HP at an angle 30 degree and inclined to VP at an angle 45 degree. Draw its projection mean. This is how we should draw. Okay, initially what to do? You have to mark the front view A dash 10 millimeter above the XY line, top view A 20 millimeter below the XY line. Draw a locus, draw a locus. At point A dash, you draw a line called A dash B1 dash true length at an angle 30 degree and get the corresponding top view called AB1. Similarly, draw AB2 length 80 millimeter at an angle 45 degree and get the corresponding front view called A dash B2 dash. So now by superimposing, I may get the front view and top view of the line. How? From AB to true length, you have to project and rotate. You will get the front view called A dash B dash. From this true length A dash B1 dash, project and rotate, you will get the top view called AB. Thank you.